Hey everybody, it's Mr. Carr again. Today we're going to be talking about 8-6 day 1, solving rational equations. Okay, so this is tying back to when we did our simplifying of our rational equations or our rational expressions. Has to do with factoring a lot with that. But today we're going to be talking about solving them. This is what we mean when we have to solve them. With a rational expression, that is just an expression by itself. So for example, x squared, say plus 3x plus 2 over x squared minus 5x plus, let's go plus 50. Sure. Okay. So that is a rational expression. To make it a rational equation, it's got to equal something. Okay. So that's what we're focusing on here. What happens when it equals something? Well, if it equals something, the difference between expressions and equations is we can solve for whatever that x value is. So in this case here, that's what we're looking at for this part. Weighted average is going to be for next video. So for now, we'll just focus on the rational equation idea. So this is an example of that. Okay, so solving a rational equation. There's a couple ways you can do it. Here's my preference. Step 1, find LCD of the equation. Okay, so when I look at this, I've got a few different things. So I've got 24, 3 minus x, and 4. So 24, if I do a quick breakdown, that'll be 4 times 6, and then we got 2 times 2 times 2 times 3. And that's 2 times 2. So if I want to identify my least common denominator, that's going to be made up of, we got 2 2's here, then we have a 2 and a 3. So it'll be 2 times 2 times 2 times 3. So we got the 2 common 2 2's and everything like that, and then another 2 and 3. 3 minus x will just be like that. So in this case, we got 24, 3 minus x. Okay, so that's my least common denominator between all three here. So what that means is I could turn them all into this. Now, instead of doing that, where I normally do the adding and subtracting, I would say go ahead and turn all the denominators into the same denominator, and then you can combine them. You can do that here and then do a slightly different problem to this. Here's my preference, though. Now, let me just rewrite everything real fast. When I do this, this is a bit of a strategy for getting rid of fractions. We don't want to deal with fractions. So instead, I'm going to do this. I'm going to multiply everything by my common denominator. Okay, so that's my step 2. Multiply by the LCD. Okay, so when I do that, that's going to distribute to everything. So I'm going to break it down a little bit further, but I'll take shortcuts in the future. So I'm going to have 24 times 3 minus x times 5 all over 24 plus 24 times 3 minus x times 2 all over 3 minus x. Whoops. And that equals 24 times 3 minus x over 4. So after I distribute that, one thing you're going to notice is all my denominators have a common factor in the numerator. 24 can divide out. 3 minus x can divide out. We're going to simplify each of these. 4 can be divided by 4, then this divides by 4 for 6. So that means from here, we can actually get rid of all of our fractions. This turns them into like just a straight linear equation to solve. So I can take 5 and distribute it here. So I'm going to have 15 minus 5x. 24 times 2 is going to give me 48, so I'll add 48 there. 6 gets distributed, so I have 6 times 3 is 18 minus 6x. Okay, much easier to solve. So I'm going to go ahead and add 5x over to both sides. Subtract 18 and combine that with the 15 here. So that's gone and that's gone. So I've got, let's see here, 15, let's see here. 15 plus 48 minus 18 gives me 45. Negative 6x plus 5x is a negative x, but then I divide by -1, and I get x equals a negative 45. And that is my answer, as long as when you look back at the original problem, I just got to make sure that if I double check that, if I look at that just like I did before, x cannot equal a positive 3. So if x were to come out solved by 3, we actually get rid of that solution. Okay, so in this scenario, it's fine because x was negative 45. That's okay answer. Feel free to plug it back in the original problem and check it, but I've got confidence in this one. All right, so let's keep going for some more examples. When we do something like this, got a little bit more complicated, but we can also do, again, just like we did before, factor it out first, figure out my least common denominator, multiply through by that. So if I factor this out, we got p squared minus p minus 5. That is going to be p, 3 minus 3p plus 2 over p plus 1. This will be p squared minus 7. So I'll just leave it like that. P squared minus 7 over p minus 1, and then plus p over 1. So if I look at that, that's pretty easy for my LCD. It's p plus 1, p minus 1. So that's what I'm going to multiply this whole thing by. P plus 1, p minus 1. Okay, so now just to kind of get an idea, to make it a little bit easier in terms of what all my simplifying and everything, p plus 1 will cancel out with this one. So all I have to do is p minus 1 multiplied by all that. So I'll turn to p minus 1, p minus 3, p plus 2. And actually, I might as well, I kind of did the factoring just to double check if I could divide it out and simplify it, which I can't. So I'm just going to leave it as p squared minus p minus 5. Okay, this one's going to cancel out, and that would cancel out here. So that gets multiplied by that. So it will be p plus 1 times p squared minus 7. And then there is no denominator here besides 1. So this whole thing gets multiplied by p. So that's going to be, let's see here, what was I? Oh, p times p plus 1 times p minus 1, which I'll simplify to p squared minus 1. Okay. So now I'm just going to multiply through or distribute and everything and figure out what my p values are by combining like terms, everything like that. So we'll see how it goes. So first thing here is if I multiply this out, I'm going to have p to the third minus p squared minus 5p minus p squared plus p plus 5. Over here, I'll have p to the third minus 7p plus p squared minus 7. And then this will be p to the third minus p. All right. So time to start simplifying as best I can here. So let's see here. I got p to the third minus 2p squared minus 4p plus 5. Over this side, we've got 2p to the third plus p squared. So here, plus p squared minus 8p and then minus 7. All right, so let's combine everything to one side. We go there from solving. So if I subtract this over, add this over, add this over, and subtract that over. So minus p to the third plus 2p squared plus 4p minus 5. Okay, so 0 equals p to the third plus 3p squared minus 4p minus 12. All right. I'm going to kind of look at that. I see that there's 4 terms here. I'm going to take a bit of a guess, and I think I can do the factor by grouping. So remember from before, I like to do that as a 4 square box. We got p to the third, 3p squared, negative 4p, and negative 12. So out of p to the third and 3p squared, I can take out a p squared. That'll be a p. This will be a 3. That should be a negative 4. And yep, that does work out. Okay. So what that means is I get 0 is equal to p plus 3 times p squared minus 4. Okay. So that means if I factor that spot one more time, I get p plus 2, p minus 2. And then I could solve each of these. So I get p equals a negative 3, p equals negative 2, p equals 2. And again, just like I did in the previous problem, double check the original. So if I look at those, p cannot be a positive 1 or a negative 1. So these 3 values, these 3 values are all good. All right. So check this one, pause it, give it a try for yourself, and do the same thing here. Okay, we're going to talk about some specialty problems in the next video, but basically that's what I like to do for my strategy is find that least common denominator, multiply it through by everything. It gets complicated with the algebra, but overall still doable. Just make sure you double check that it doesn't create a 0 in any of your original denominators. All right, that's it for today. Take care, everybody.